All right, guys, this is lesson 4.1. This will be our first video on this, and it'll probably take 2 or 3 videos to cover the whole lesson. We're going to look at now the graphs of a sine and a cosine, and hopefully the last day or two you've been enjoying kind of making those graphs on the paper with the sticky notes and coming up with what a sine and cosine graph look like, and it's going to be a really nice preview into what we're doing here in this section. But just to kind of give you some context of this, we're going to graph sine and cosine. And a word that comes up that'll be important is a periodic function. And a periodic function is going to be a function that repeats its value over and over, and it's a regular pattern. And of all the functions you would have graphed in Algebra 2, none of those were periodic. You may have graphed a parabola, or a circle, or an ellipse, or a line. But once you graphed a parabola, so you had your parabola, it didn't repeat later, and you didn't get another parabola further down or over here or something like that. When you graphed a parabola, you got one. The sine and cosine graphs will be different. They keep repeating, and you maybe didn't get that sense yet with the sticky notes, but you're going to get the stickers when we made that, but you're going to get that sense as we go through today's lesson. Okay, why would you want to graph something that's periodic or something that repeats? Well, the answer is because lots of things in nature are periodic. And you can think of all sorts of examples. We have some examples here. Have you guys ever noticed in the summer it gets really hot every year? And in the winter it gets cold again? And it does it every year. So it just keeps repeating like that. So temperatures over a period of a year repeat. Your heartbeat, hopefully it's periodic, about every second it beats. Amusement park attendance, in the summer it's way up, in the winter it goes down. Electrical current isn't actually an alternating current. Goes between a pot, going one way, then back the other. Gas prices sometimes are periodic. They go up in the summer or maybe around the holidays like Memorial Day or Labor Day. Then they go down other times. So certain things in nature, and you can think of lots of things that just repeat. Okay, why would we want to know about periodic functions, or why are we studying those now? Because it turns out the sine and the cosine graphs will be periodic functions. And we'll be able to use sine and cosine to model some of these things up here. In terms of periodic, it's like, okay, how long does it take it to repeat? Well, a sine and cosine will repeat every 2 pi radians. If it was in degrees, it would be 360 degrees. We're much more likely to use radians in this chapter. So every 2 pi radians, a sine or a cosine is back to where it started. And that's why we're going to study these, because they're periodic, and lots of things in nature are periodic. All right, let's look first at a sine graph. And we've already made this table. Hopefully you're familiar with it. You could take it off your unit circle, or whatever. Like I said, we've just made this table before. And this is sine. We have different angles here, 0, pi fourths, pi halves. So I don't have all of the angles, but some of the angles. And then here are the sine values. You might think, wait, wasn't the sine of pi fourths, that's a sine there? Wasn't that really the square root of 2 over 2? Which it is, but we're going to graph this, and it's hard to graph the square root of 2 over 2. But if you figure out the decimal approximation, it's 0.7. Okay, so if you look at some of these, they may not look completely familiar. But if you punch them into your calculator, you'd say, oh yeah, it's the same thing. It's just an approximation. So in our graph here, I'm going to come down here to the end, and this is going to be our 2 pi. Why there? Because that's how long a sine, it's going to take a sine function to repeat every 2 pi. If I do that, this will be pi, this will be pi halves, this will be 3 pi halves. So we're tick marks here are every pi halves, 1 half, 2 halves, 3 halves, 4 halves. All right, I look at my y's, the biggest it ever gets is 1, so maybe I'll call up here 1, and down here -1, because I want to use most of my graph. And I start to plot these points, let's use a different color. So 0, 0, that's a nice easy point to plot. Pi fourths, 0.7. Pi fourths would be right here between 0 and pi halves. 0.7 would be just about there. So there's pi fourths, 0.7. Pi halves, we're up to 1. And as we're doing this, hopefully think, oh, this looks like the graph I was making in class. 3 pi fourths, we're back to 0.7. Pi, we're back down to 0. And look at this, 5 pi fourths, that's -0.7. 3 pi halves is -1. 7 pi fourths, that's -0.7. And 2 pi, we're back up to 0. And we don't have a lot of points here. You did more in class. We did every pi twelfths in class. but you get this sense of a nice smooth curve that hits these. And this is something you'll want to know off the top of your head. This is what a sine graph looks like. And again, you made one by hand, so hopefully you look at this and say, oh, that's already kind of cemented in my brain. Okay, so if you graph it in a calculator, you get a lot more pixels here, but you get a graph that looks like this. And again, if you labeled it, we would know this is 2 pi, and we know this is going up to 1 and down to -1. Okay, you were expected to be able to graph a sine graph. You won't have to plot as many points as we just plotted, but you will want to know 4 key points. And you can look at the chart and say, wait, it looks like there's 5 here, but 2 are the same. So you'll want to know at 0, the sine of 0 is 0, and since the sine graph repeats every 2 pi is the same thing. So I would count this as 1. You might count it as 2. So I'd call it as 4 key points. You might be thinking 5, whatever. So sine of 0 is 0, sine of 2 pi is 0. Sine of pi halves, you'll want to know is 1. Sine of pi is 0, and 3 pi halves is -1. If you're thinking, oh no, not more memorization, I would agree. It's not more memorization. It's the same memorization. Remember the unit circle? And remember that this was 0 or 2 pi. Remember that this was pi halves. This was pi. This was 3 pi halves. And this was back to 2 pi. Remember that? Remember our coordinates here. This was 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. A little low, but right over there. Well, sine, remember the y coordinates. So you can see this from your unit circle. The sine of 0 is 0. Sine of pi halves is 1. Sine of pi is 0. 3 pi halves is -1. And 2 pi, you're back to 0. So guys, these are just the same values you've had from your unit circle, the same values you've had from your chart. So is it more memorization? No. It's just looking at those same values we always had and just seeing it now in a graph form, where your x-axis is now the angle in radians. And then the y-axis is your sine. All right, so that is your sine graph. That was fun. Let's do the cosine graph. See what that one looks like. And again, you did this in class, so it's not going to be a huge surprise. But if you wanted, you could plot similar points. And again, you know where these came from, the same kind of points we'd make about the cosine graph as the sine graph. These are approximations here, 0.7. It's really square root of 2 over 2. So it's going to come down here to 2 pi. Here's our pi's. You always want to label your graph. This is pi halves. Here's 3 pi halves. It goes up, so we'll call that 1, down to -1. And let's plot our points again. Cosine of 0 is 1. And again, is this more memorization? No, it's not. This is just your unit circle. Now it's the x-coordinates. So go back to that unit circle for a second. And now we're just doing the x-coordinates as we work our way around there. All right, so come back here. Cosine of 0 is 1. Cosine of pi fourths, oh, look at that, 0.7 again. That's nice. Pi halves is 0. Then 3 pi fourths is -0.7. Oops, I missed that. Oh, that's about right. And then pi is -1. 5 pi fourths, -0.7. 3 pi halves is 0. 7 pi fourths is 0.7. And 2 pi is up to 1. This might look like a V, but you've plotted more points in class, so you know it's not a V. It's really this nice smooth curve that hits those points. And that is your cosine graph. So again, if we looked at a calculator representation, looks like this. What are your key points that you need to know? These 4 or 5 key points. Cosine of 0, you want to know is 1. Pi halves, 0. Pi, -1. 3 pi halves, 0. Where does that come from? You know it. Unit circle. You know these values in your unit circle. Back here to 2 pi. And cosine now is the x-coordinates. So the cosine of 0 is 1. Cosine of pi halves is 0. Cosine of pi is -1. And 3 pi halves is 0. So if you ever forget these points or get confused, just work your way around the unit circle yet again. All right, so that's an introduction to our sine and cosine graph. And our next slide, which will be our next video, we're going to look outside that 0 to 2 pi window to really see the periodic nature of this.